Welcome to the first video of Chapter 2. Today's video is about Section 2.1, which is Use Inductive Reasoning. So we have two different objectives for today. First, we're going to describe patterns and find the missing terms, and then we're going to use inductive reasoning, which is again more with patterns. So today is a lot about patterns. This video has a lot of examples, but I'm going to be completing most of them because it is so much background information. So my first question is this one that you see with the boxes. It says, which is next? And I know on your notes you don't have these colors, but we notice we have one box here, we have 2 by 2, 3 by 3, so it's logical that the next one would be 4 by 4. Sorry that my drawing is not perfect. And then we have to fill in those boxes in between. So here there was 1, and then we're going to be adding 4 in. Okay. Then I wanted to know, did you take color into account? You see what the boxes should look like. What would be the next color? So red, orange, yellow. It's color after yellow. Well, in the rainbow we have Roy G. Biv. So red, orange, yellow. So my guess would be that this next one is going to be green. Okay, so that's part of what we're going to be doing today. Here we have example 2. It says describe how to sketch the fourth figure, and then actually sketch it. Right now, pause the video and sketch the next figure. We will then write the description together. Play the video when you have completed it. Okay, so you should have known, or should have noticed, that we have 1/2, then we have this half cut into 2 pieces, then we have this half cut into 3 pieces. So the fourth figure, the half should have been cut into 4 pieces, and then you should have done the same for the other half as well. And we always have one part shaded, so I shaded that part. So that's what you should have gotten for the figure. It also says describe how to sketch the fourth figure. So I'm going to say we're going to draw a circle, and we're going to divide that circle into 8 congruent, I'm going to call them sectors. I just really mean slices. And then you are going to shade 1 slice. Okay, so part of what you're going to be doing when you come to class is you're going to be working with these figures and finding patterns in figures. Sometimes, like examples 3 through 6, you're going to be finding patterns in numbers. So looking at example 3, we're supposed to find the next term. To get from -5 to 2, we add 3. To get from -2 to 1, we add 3. To get from 1 to 4, we add 3. So add 3 again, and our next term would be 7. Okay, so 1, 4, 9, 16. To get from 1 to 4, I add 3. Then I added 5. Then I added 7. Now if I add 9, I will get 25. The other pattern that you should have noticed is 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 then is 5 squared. Okay. Example 5. To get from 1 to 2, I add 1. To get from 2 to 3, I add 1. And then I added 2. And then I added 2. And then I added 4. And then I back to adding 2 again. So I'm not adding a constant number. So this has no pattern. Pause the video right now and try example 6 on your own. I will tell you that this is a special pattern. There is a pattern, so don't write no pattern. Okay, so for 6, you should have found the next term to be 55. 1 add 1 gives us 2. 1 add 2 gives us 3. 2 add 3 gives us 5. 3 add 5 gives us 8. 5 add 8 gives us 13. So each term is the sum of the previous 2 terms. So if I take 21 and add 34, I get 55. This is a special sequence that comes up a lot. This is called Fibonacci sequence. So it comes up a lot in mathematics. Okay, moving on. A conjecture is an educated guess. Educated guess. It's kind of like a hypothesis in science. So an example, the sum of two odd integers is, well, let's pick two odd integers, 3 and 7, that gives me 10. 5 and 11 gives me 16. 9 and 11 gives me 20. Anytime I'm adding 2, what do I notice about the sum? Well, I notice that the sum is even. So the sum of two odds is always going to be even. Right now, pause the video and you try this second conjecture on your own. If you're not sure right off the bat, write out a few examples like I did. Okay, so it says product, which means multiply, of an even positive integer and an odd positive integer is, okay, so even multiplied by odd, even multiplied by odd, even multiplied by odd. I notice that the product is always an even positive integer. Okay, even positive integer just means that there's no decimal, no fraction. So if you got that one right, good for you. If not, that's okay. We'll be doing some more examples. If you have a question on how I got that, make sure that you write it down. Now, if you would please flip to page 6. Okay, so now we're going to talk about the two different types of reasoning. Inductive reasoning, which is what this whole section is all about, goes from specific to general. And deductive reasoning goes from general to specific. Deductive reasoning, that's kind of what detectives use. They have a general situation and they have to look for very specific pieces in order to break down the whole situation and find the one suspect that they're looking for. Okay, so we have example 7, which is about conjectures again. It says, given 5 collinear points, make a conjecture about the number of ways to connect the different pairs of points. Okay, so 1 point, that just looks like that. Sorry, that should be a point. There are 0 ways to connect that point. 2 points. Okay, connect them. Well, there's only 1 way to connect them. 3 points. This is where it gets a little more interesting. You have 1 way to connect 2 of them, another way, and another way. So 3 ways to connect those 3 points. 4 points. Okay, so I have 1, 2, 3, 4. But then don't forget about 5, 6. So you're just looking at the connections between any pair of points. Okay, so let's see if we can find a pattern. To get from 0 to 1, I add 1. To get from 1 to 3, I add 2. To get from 3 to 6, I add 3. So I think that I'm going to be adding 4 next time. So 6 add 4 is 10. So let me draw myself a picture and see if I was right. Okay, so I have 1, 2, 3, 4, 5. And I have 6, 7, 8, 9, 10. So there were 10 ways to connect the points. Okay, so moving on. A counterexample. So this vocabulary word here. A counterexample is an example disproving a statement. An example disproving a statement. So you're given 3 statements, and all the statements are false. In order to prove that they are false, you have to give me a counterexample. Okay, so the first one, for all real numbers, 2x is greater than x. So for all numbers, if I multiply that number by 2, it's going to be greater than the given number. Well, what happens if x is negative? So if x is negative 4. So 2 multiplied by negative 4, is that greater than negative 4? Is negative 8 greater than negative 4? No, because they're negative numbers. So one counterexample would be x equals negative 4. Another one might be negative 5, negative 10, negative 100, 0 even. Okay, all quadrilaterals are equilateral. So every four-sided figure has congruent sides. Well, that's not true. What about a rectangle? Okay, so here I have my rectangle. That's definitely a quadrilateral, but it's not equilateral. So that's a counterexample. Right now, pause the video and you think of a counterexample for the third statement, please. When you are finished, come back. Okay, if an animal has spots, then it is a leopard. You should have come up with an animal that has spots, but that is not a leopard. The one that I happen to come up with is a cow. A cow has spots, but it's not a leopard. Okay, so moving on. I know we covered a lot today, but the objectives for the day were to describe patterns and find the missing term, and then to use reasoning, which is what we did with the conjectures and the counterexamples. When you come to class, we're going to be doing examples covering everything that was in this video. You have one example that you need to do on your own. It says, find a function rule relating x and y. So you need to think, what am I doing to x here to get y? What am I doing to x to get y? What am I doing to x to get y? And you need to write an equation, please. When you come to class, I'm going to be checking that you have all the examples done, all the work shown, and that you didn't just copy what I did in the video. You also must have this problem completed in order to get full credit. Good luck!